Okay, we're going to get going with our final session, which is the identity panel, which we have Andy Smolik from Google to moderate, and I'm actually on the panel, but there's no chair, so I'm just going to steal the microphone from people when when it's my turn. Okay, so let's get going.
And what we'll do is, I guess, John, why don't you give a, oh, no, you've got a slide here too.
Yes.
Okay. So I'll be letting each of the participants step up for a few minutes. They've each got one slide to set context. I'm Andy Smolik. I'm on the Android team at Google. Been working mobile identity and at CIS for years and years and years. And we always come up with, what is the thing this year that is happening, that is challenging, that's messy, difficult, or not necessarily the easiest thing to do, but that everybody wants to do. This year, I think it was pretty obvious. Everybody is trying to be able to determine, is this device that is asking me to authenticate, if you're the identity provider, is this device managed? What should I do in terms of the answer that I give based on that? And what we've got with each of the panelists is what are they doing in this space? What are their thoughts on how to attack the problem? Is there a one-size-fits-all for how you do this? And we'll go from there. So, Steve, you're up first. Why don't you introduce yourself and jump into the context?
Thanks, Andy. Steve Wilson from Constellation Research. I'm an identity guy. I've got two identities. I'm also with Lockstep Technologies in Sydney. And it's with that cap on that I'm going to talk about provenance of devices. I've been in PIC-AI for 20-something years, and PIC-AI has some baggage, to put it mildly. It's got some historical preoccupations, purist preoccupations with public keys and with identity. And what we're doing with the Department of Homeland Security in a project called MDAV, Mobile Device Attributes Validation, we're trying to break this obsession with public keys and identity and shift the agenda, if you like, to attributes and private keys. The private key historically has got almost no attention in classical PIC-AI. And that's sort of a malady that even infects blockchain. It was, if you think about blockchain, it took 3 or 4 years before anybody came up with a hardware wallet. And how many hard drives were lost and trashed in the meantime, as if the private key never mattered. I mean, it was incredible failure of the blockchain sort of imagination early on to realize that private keys were really important. So, private keys, secure elements. I just want to talk about what we're doing to provide provenance of devices, because that's the theme. And this is one element. I'm going first because it's probably the lowest level, most basic part of what you're going to hear today. I might not even get a chance to say anything more because it's so low level and so basic. The MDAV project is about forming a logical triangle between an individual, a device that they control, and an attribute authority who knows the individual well enough to give them an attribute such as a first aid certificate. What we're doing is producing a private key pair, a public key, private key pair, with the private key assured to be in a secure element on a known mobile device. Under those circumstances, if we issue a digital certificate on behalf of the attribute authority, signed by the attribute authority, issued against the public key that matches the private key, then you form this logical triangle, understanding that the user controls the device is PIN controlled or fingerprint activated, doesn't really matter. People control their mobile devices. We can assume that they don't lose their mobile devices. There are billions of mobile telephones that are out there that we rely on day to day based on a tacit assumption that people don't lose their phones. And when they do, on average, they take less than 10 minutes to report them and get them fixed. So with that triangle in mind, what it means is that if you are the relying party of a transaction that has been digitally signed with a signature that is validated by that certificate, then you know that that transaction had to have come from the device of known provenance, activated, PIN protected by the known user. And the cool thing is that the known user's identity is not actually an attribute. It doesn't appear in the certificate. What appears in the certificate is the thing that matters in the context, like their first aid certificate. So as I said, it's a very low-level idea. It's about relying on the fact that the secure element controls a private key. You use that private key to sign artifacts, transactions, and you know where those transactions have come from. Ergo, you know a lot about the provenance of the device.
Thanks, Steve. Carl.
Cool. Karl McGuinness at Okta. Okta is a cloud-based identity provider and also has an EMM solution. So what I wanted to do is sort of just talk a little bit about how we've had to navigate this sort of mess in a sense of looking at every single SaaS app out there. How can we solve the problem for the breadth of SaaS apps, not just a particular SaaS application? And looking at the different challenges. So everybody has done the flow before where they launch their native app, and the native app will kick off a flow to the identity provider to authenticate the user. And at this point in time, you have the ability, depending on how that was launched, we just, in the previous session, looked at the difference between web view and app auth. Are you embedded the web browser? Is the web browser the system browser? That gives different capabilities to the authentication flow, such as can I read a certificate or can I not read a certificate? All depends on, for example, the ISV choice of how they actually launch that flow. And then there's the ability to do the swizzle over to another native application as well to be able to potentially augment some of that experience. So if you have another authenticator app on the phone, you could potentially link over to that phone application to potentially augment the flow at the risk of user experience of getting them back to that original context. And then after the flow, single sign-on back into the SaaS application, you typically hit the OAuth server. And at this point in time, the IDP and the EMM are traditionally out of the flow. And so now the OAuth server is releasing the tokens, has no idea about the sort of provenance of the device that's being axed. All it knows is the client identifier that it, traditionally even in a mobile application, a public identifier for the application to be able to release the token. And then from the life of that session or the life of that app on the phone, it's just using tokens to hit the background API server. So if there ever is a device posture change or any other security event that happens, it's continuing going on using those security tokens. The IDP is out of the flow, the EMM is out of the flow. Now the EMM can do sort of the nuclear option and just sort of kill everything on the phone if it's under management control. But the challenge here is that you have OAuth going on sort of independently of the IDP. The attestation potentially that you could have gotten through the certificate, if it happened to have been written in the right app auth type pattern, is out of the picture. And then on the top right, you have the fact that even your SaaS applications have APIs, and whether it's a developer, whether it's another connected application on the device, you have other applications than just your employees hitting those REST APIs. Again, no attestation there. So the challenge here is that there's really no sort of technology solution across iOS and Android that works across every SaaS product to sort of meet this need. And so you're left with sort of best of options based on capabilities of the device, based on cleverness of the solution to sort of get there at the risk of security and usability. And so that's sort of where we're currently at the game, is sort of trying to fill as many holes as we can with as many sort of workarounds to sort of cover the widest range. And it's not really where we'd like it to be.
Thanks, Carl. Did you do a proper intro?
Good enough.
All right, William. Now that we've kind of set up the challenge here.
All right, so William Dennis, Product Manager on Google Cloud. And I have kind of one very specific contribution to this, which is this internet draft. And this was actually born out of a discussion last year, I think at probably the last CIS, where we were trying to come up with a way of transmitting signals about the device. And we went through a rather complex sequence diagram that should probably be burnt and never see the light of day. I believe the words magic pixie bucket were included somewhere in it, so it's really not a document you want to read. This one, however, is a fairly simple document, and it's just a spec for transmitting signals from the app to the IDP. And those signals could be a very simple, like a Boolean that simply indicates, does this app have a lock screen? Now, you can actually combine that signal with an OS assertion and potentially token binding, which is some fairly advanced technologies. If you do that, advanced and I guess not quite generally available, but if you actually do that, then it can be a trusted assertion from the app. If you don't do that, then it's just an untrusted app assertion. So it's basically just the app saying, hey, this device has a lock screen. So you might be wondering, like, what's that useful for? If any bad app can simply claim to do that. Well, it does protect against one thing, which is what I call the hapless user. So let's say this is a non-malicious user. This is a user that wants to do the right thing. They've brought their own device, so there's potentially no EMM on the device. It's a very straightforward, simple setup, and you want to protect against them just leaving the phone at a bar, for example. And so by sending that type of signal, the app can basically say, yes, this app has a lock screen, or no, it doesn't. And the IDP can act accordingly, and you can sort of protect yourself against that sort of accidental, non-malicious problem. So that's what this spec is. Yeah, if you find it useful, please send through comments to this group, and we might actually publish it.
Thanks, Andy. Hi, my name is Ashish Jain. I lead product management for identity at VMware. So I want to build on top of what Karl and Will said, that the problem we have on a mobile device is primarily because the embedded browsers do not have a way to share context across different applications. So you cannot do things like single sign-on. You cannot find out whether or not the device is managed. So one way to solve the problem is similar to what we described earlier, that you can use app auth or you can use app attestation. The other alternative way to solve the same problem is to use EMM or MDM. So before I go any further, let me ask you this. How many of you know what MDM or EMM means? Okay, almost like 60–70% of the room. So for the remaining 30%, it weighs all the major OS platforms today, iOS, Android, Windows 10, and Mac OS, gives you a common set of APIs to remotely manage and monitor your devices, including things like PIN code enforcement, DLP, encryption, compliance check, and all that. So if you have an EMM in place, then there is a way that you can solve the problem that we discussed earlier. So this is the simplified version of the diagram that Karl showed earlier, that as a user, I come in, access the mobile application. It goes to the backend server. This is the OAuth handshake. I redirect it to an IDP. This is the SAML handshake. The IDP goes to the AD, does the authentication, comes back, and the user has access. Because of the embedded browsers, this flow has to happen for every application. However, if you have an EMM in place deployed, then the flow can change slightly. And the way it would work is that the user would access the mobile app. The app will connect to the server would redirect to an IDP, and that's where the IDP now can check if the user device is managed. It can, or it's the mobile device, it can redirect that to an EMM endpoint. The EMM endpoint, in that case, will now check whether or not this user is logged in. It has a right compliance policy implementation on the device. And if all of that checks out, it's going to redirect it back to the IDP. IDP can then redirect back the SAML response to the application. The application can now issue the access token, and the user is now logged in. The benefit of this approach of where you combine the EMM and the IDP is A, that you do not have to make any code change or application SDK deployment in order to achieve this result. Second, even though there are slight differences in terms of the handshake between the EMM and the app, it does works across iOS, Android, and Windows 10. And then the third part is that in addition to giving you the mobile single sign-on, it also tells you at runtime that this application and this device is per compliant to your enterprises. Now, this solution will not work for all scenarios, especially when you have Facebook or your banking applications, because in that case, the EMM may not be relevant. However, for the enterprises who are trying to use their employees to access cloud applications like Salesforce, WebEx, and without any code changes, without having the need to modify to either SVC or the browser tab that we discussed earlier, this solution does provide a very good alternative today. Okay? Thank you.
So we ran out of chairs for me. So I'm going to have sort of an opposite hypothesis from the sort of top-down EMM point of view. And they're not necessarily mutually exclusive, but we see a lot of banking apps. Banks have a hard time getting their consumers to install EMMs on their mobile devices. Hospitals in the health industry, a lot of doctors work at multiple hospitals. Fighting competing EMMs quite often, yes, I can see that you've been there, quite often causes lots of interesting interactions. So imagine if we start designing the apps to actually take some responsibility for themselves, if we can use the attestation services on Android on Windows, the crappy one on iOS. In combination with things like token binding, you can actually get a proof of possession assertion from the operating system about what the app you're talking to is. And a lot of the time, people are installing very EMMs that provide a lot of value for their dollars. But just to figure out whether or not they're talking to the frickin' right app. So if the app itself could make an attestation about, yes, I am actually this application and I am actually working on a device that hasn't been rooted, that's an important piece of the authorization information. And you would think that, ideally, every time you do an OAuth authorization, knowing that you're talking to the right OAuth client, it's got the right developer key, the right app ID, it's in a safe environment. So knowing who you're talking to, whether it's on the person's BYOD device or on an enterprise device, is almost irrelevant if it's secure. If the user is doing, who the user is, and they're perhaps doing the right multi-factor authentication, if you know that stuff, you can let them do the appropriate things, whether or not they necessarily have an EMM. And once you actually have the ability to know that it's your own app, you can have error signals like erase all your cached information. One of the nice things about that is that as a bad guy, on every fourth Thursday when I get to do that, the first thing I would do is block the communications of the phone to the EMM back end, which then lets me do whatever I want with the phone for about 24 hours, or whatever the polling interval is. What you can't do is block the communication between the app and the actual API, otherwise the app doesn't work. So, rely on the channel that can't be blocked by the attackers and have strong authentication of the app, the device, and the user. We can actually start using the OAuth authorization server as well, an authorization server, so that you can make those policy decisions. So while the existing applications probably have to be managed by an EMM, what I'm suggesting is that the combination of AppAuth and attestations from OAuth, along with the token binding, start letting us improve the quality of the application so that we can actually manage from the bottom up as opposed to the top down.
So let me start by asking the panel, is there anything that is kind of like a single pattern that everybody should just start using and it solves this problem, right? Does the use of certificates magically make all these problems go away? And let's just run down the.
Sure. So I think at the end of the day, it depends on a variety of things. It depends on the scenario and the applications that you have. For instance, John mentioned the banking application and the hospital applications. It also depends whether or not you have EMM in place. It also depends what kind of devices you have. In general, when we talk to enterprises where they have multiple devices types, they have multiple app types, both internal and external, which are in their various degrees of adoption in terms of AppAuth and app attestation. The solution today seems like a hybrid solution combined with the EMM and in some cases use the AppAuth libraries. So I think before we can give this is the final answer for all app types for all devices, you kind of need to look into what are the different type of use cases you're trying to support.
So definitely getting the application not in the business of collecting credentials is the best starting point, right? So that we're in a debt problem today because applications directly, whether it's hosting WebView or name password inside the application. So externalizing that from the application allows both the IDP or the AS or the system operating system to advance from iOS 1 to iOS 11 and deliver new capabilities, whether it's FIDO authenticators or whatever it goes forward with. So we're in a debt problem because applications weren't written with those in place, and now we're trying to figure out how to get coverage around it. So getting that out of your application is the number one thing, and certs aren't ever an answer because TLS was never really built for this use case of trying to do device identity with user identity all in the same sort of use case, and then how that represents itself in the system browser is everything from hinting to control to the user experience to everything around it. It doesn't seem like it's ever going to be there. And so there's hope that we can finally solve that with the WebAuthn standards and really have a sort of origin-bound sort of PKI-based approach that might actually be user-friendly. So hopefully that's sort of the next step to sort of align behind is what I'm hoping.
It's kind of a minor semantic point, but Karl said certificates, and the next sentence he said TLS. And it's not like certificates are TLS in my mind. And so maybe that's not what you meant, but I think it's a good example of there's some really, and this is not you being muddled, but there is generally muddled thinking about what certificates mean and where do they belong and what is PKI anyway. Like I'm having an argument on Twitter with somebody at the moment who says, look, you don't need PKI, but you do need crypto. And I said, well, what's your allergy to PKI? Your allergy to PKI is that the old VeriSign model from 20 years ago and SSL and TLS, all of that stuff is really, really difficult. But it's not as difficult as some of the other things that we do in software all the time. And so to John Bradley's point about, and I'm going to leverage John's point about applications taking responsibility for their own attestations and for their own hygiene. Well, while we're at it, why don't application developers just take some more care with security generally? There's a lot on your plate, I know, but it's not. These problems are not intractable. So what we're doing with this MDAV project with Human Services is that we're actually leveraging existing absolutely standard PKI, but changing the certificate profile so that the certificates that we're issuing to mobile devices don't contain name and birth date and KYC information, but they just contain single snippets that are important, and we're putting that into what we're calling an attribute certificate. It's not unlike the FIDO attestation certificate. So I wrote a long analysis of FIDO a few years ago when it first started, saying this is PKI as nature intended. And it's throwing off some of that baggage, the I part. In fact, one of the FIDO doyens, Stina from Yubico, says it's PKI without the I. And again, what she's channeling there is this allergy to big PKI and big CAs, and I get all that. But there are some existing CAs out there that are all too happy to work with you to generate special purpose certificates to create attestations of all sorts of things. And if we can bind those to devices, then we're going to solve that provenance problem. Not to say that get a certificate and everything's fixed by any means, but let's just think better about it.
I guess I'm inclined to agree that I think client certificates are probably not going to be the solution. I did mention that in the talk earlier, but it was kind of more just to make the point that, with the AppAuth model, you can use everything the browser has. It doesn't necessarily make it a usable flow. And I guess on the topic of certificates, it's interesting to me that token binding is relying on the private key. But the nice thing is that it's just a client-generated private key. It just doesn't really, the private key kind of has no authority itself until you actually authenticate a session, and then you can potentially bind that session, which I think is very powerful.
Yes, as someone who started off in the PKIX business years ago doing LDAP servers, I agree that, well, it's mostly the X that I'm allergic to these days, not necessarily even the I. So there is a big difference with this kind of attribute certificates where you're actually using them in the application and not, you have to imagine, everybody generally has an experience of the horrible experience trying to do mutual TLS and the browser certificate selection, but you can do a much better job if you're actually doing it in the application. The biggest problem that we really have around that sort of FIDO has been trying to address is correlatability, that if you have a single private key on the device that all of the certificates are tied to, even if you're only asserting over 18, then multiple sites can tell that it was you because it's the same key. So you have to, there are some more sophisticated things that you need to do with creating pairwise identifiers, but all of that is possible, and Steve is going to have a rebuttal.
Absolutely agree. One private key, complete disaster, but we advocate one key pair for every attribute. It could be hundreds of attributes. I mean, this stuff is cheap now. Absolutely cheap to do. And so absolutely we should be doing non-correlatable private keys that are very, very context specific, like FIDO.
But you also have to have a different private key for each audience would be what the privacy people would argue. Otherwise, you can correlate who has the attribute across the places that you assert the attribute. Right. But there are, it's not an intractable solution. So depending upon how we do attestations and other things, that perhaps this, we did InfoCard, I don't know, Mike and I did that, 7 or 8, almost 10 years ago now. The world has moved on, and perhaps we are getting closer to being able to do, stop laughing at me. Yeah. Yeah, we all got, done by that. But perhaps we are actually, with web authentication and some of the new assertion formats, perhaps we are getting closer to actually being able to do something like we imagined 10 years ago, which is, not actually all that unusual in this industry. Only 10 years later, you can actually do what you thought up.
Just one comment to that, though. One of the challenges is the fracture between getting Apple to sort of sign on to sort of these challenges that we're talking about here in the enterprise space, and consistency for an ISV to be able to ship applications and sort of cover the fact that it's a huge portion of the install base. So as we're talking about channel binding, as we're talking about web authenticator, web authn, getting that into an iOS shipping device is a different challenge.
Well, from an app point of view, there are, we have been talking about, Ian, when are you going to have token binding added to the app auth library for iOS?
Sorry, I was in a totally different world there for a minute. Yeah, so this is something that we've been working on. I believe we have some beta backend support for this for Google Sign-In, and we're kind of trialing on the app auth side. So there are some tricks involved with making this work with older devices and so on. So that's the things that we're concerned about. But as soon as we have something that works, it'll be going straight into app auth mainline, so everyone who pulls the library will get it.
So we may not have to wait for Apple to add token binding to iOS natively. We may be able to include it in the SDKs, etc. As long as the SDKs can use the secure element to store and retrieve elliptic curve keys, then you're actually not in that bad a situation.
It will still take a lot of time for all the app developers. So I get the point around token binding and app attestation and Pixie and all that, but to be able to wait for all the app developers to take that into the application, including all the ISVs, and for Apple to fix the SVC issue that with the iOS 11 and so forth, you still have a long time to wait, and to be able to completely rely as an IT admin on the different app developers that they are consuming within the enterprise is a tall order.
Well, that's completely true. I mean, we have what you do with the existing deployed legacy applications and the communications that we have to have to the app developers so that we don't have app developers keep following bad patterns. So we have to do both. There's an existing ecosystem out there that we have to support, but we have to communicate to the app developers, look, these are the new patterns, this is how you can do it better in future so that we're not dependent on.
So I think that's the right message to kind of get across, which is this is the right pattern for app developers going forward, and this is what you can do today.
We're getting close on time. I want to make sure the audience has an opportunity to ask some questions to the panel, since we've got so many represented here.
Questions?
While you're looking for questions, let William finish his thought.
Yeah, I was just going to make one comment. When it comes to adoption, I guess the experience I saw with Apple is that there's a lot of power in combining the specification with an implementation that's open source. And I think we saw a much faster adoption having that. So there's the RFC that anyone can implement, and then we sort of have that reference implementation. And so I guess that's what we're trying to do with token binding in a way, and maybe that can help speed up the deployment.
Right, and Ping has, there's going to be some other demonstrations of token binding and Ping Federate and Ping's products in other presentations later.
So in reference to something that John mentioned, that the applications or the resources themselves should take more responsibility for their own security concerns, and someone mentioning in a previous conversation that proxies are making their way back into the industry. Is that something that could potentially be leveraged on the enterprise side to solve some of these problems? Because proxies can then start taking advantage of incoming tokens, potentially searching for additional attributes and then making authorization decisions.
Anyone want to take that one?
Yeah, so I think there always will be debate whether or not the smartness should rely at the application layer or at the abstraction layer. There's a reason why the SiteMinder and the Oracle Access Manager is still a billion-dollar industry, because there's a lot of applications which will take a lot of time before they can implement the patterns that we implement. So I feel like the new applications they have a lot more toolkits, like what William mentioned today, that they are able to adopt and quickly come up to speed as compared to learning all the security smarts. However, for the existing applications, it will be a long road, and I think that's where the proxies approach will continue to help.
So we already have Nginx and Apache that have added token binding, et cetera. The attestation stuff, we're mostly thinking of having the authorization server being able to deal with that as part of issuing new tokens, but certainly being able to issue proof of possession, access tokens using token binding, having those tokens validated by a gateway, et cetera, is something that you'll see a demonstration of later if Brian's demo comes together.
Any other questions? Got one in the back there.
So I think I like Karl's summary probably the best, was the clearest. Said, get the app out of the business of trying to manage secrets and sessions and caches and such, and then try to move over into something that resembles better strong authentication, something like one of the FIDO standards. What else? In the FIDO standards, I assume part of what John was reflecting was we have a few of the attributes that people are looking for. There is this abstract concept called the authenticator that's proxy in some sense for the user, the app, and the device. There's device attestation in some cases that'll get better. It's pluggable, so you can put your own attestation scheme in. What other elements would be helpful to solve this particular pattern problem?
That FIDO can work on.
Anyone want to respond to that?
I didn't get the question completely, so.
I don't know what we're in. So the question was, FIDO has the ability to pass a device attestation as part of the protocol flow, and so that device attestation could come from, it's a pluggable part of the FIDO stack, so you could plug into that, whether it's a EMM or an OS or something, could plug that device attestation check into that part of the layer, into the offloads. So if FIDO was, protocol stack was to gain new capabilities, what would you ask for to help address this problem? I think the problem is this starts going down to some level of, I don't know the messaging, so I don't know if it supports all the same level of PIN policy and everything else, so I'm expecting that that's the layer you want to plug in. And so I think as long as the simple attestation checks from everything from screen lock to has PIN to has device encryption, it covers what we're seeing to be pretty much the 80% use case. And if we can just get there, that's a big win. So I'm not even thinking about the next 20%. I'm trying to focus on that first 80, which is, does it have a PIN code policy? Does it have device encryption? And is it locked?
So I think one of the interesting potential FIDO enhancements might be the touchless U2F, that actually being able to use the U2F, having a server client actually use U2F, which has an attestation which is tied to the token binding, to actually do its authentication, where that server's key can't be hijacked by a third party. One of the things that we have seen are attacks on the client credentials. So I think potentially beyond user authentication, there may actually be device authentication that could be leveraged from FIDO.
So I think just as a matter of clarification, both UAF has a concept of silent authenticator. I think that's one of the elements that's under discussion, I think, on the 2.0 track as well. So
We've got one last question right behind you.
So you've been talking a lot about me vetting a device, which we could talk for hours about how the dilemmas of that, right? But I guess one other thing I'm interested in knowing is we seem to get to this point where if your device passes these checks, then you assume that it is good to go and that people can download crazy apps and whatever. Has there been any talk about basically doing the opposite, which is like checking with the IDPs to say, this application has passed checks and it can get to things like contacts and email and whatever to say, once you're in the phone and it has passed all those checks, it's not just the Wild West of now. I hope that the user is smart and is making a decision to say, why am I allowing my game or my quote unquote flashlight app to get all these contacts and everything else? Most users I watch on their phone, they'll just smash the accept button until they get in the app, right? So I'm trying to figure out, is there a way to kind of use the IDP to make informed decisions about these apps have been blessed and here's what they can get to?
I'd argue for that one specifically, take a look at what Work Profile does on Android, for instance. It allows you to completely separate that. The intent resolution is completely separate for work apps and data. The content providers are completely separate. And that works in a BYOD scenario. You'll have to ask Apple. There's a lot of questions that everybody has for Apple, especially after this this latest. In fact, this is, I guess, a great segue into what's going to happen in this room next, which is those that are interested in discussing what Apple just did to us in the security and identity community, and that have use cases that are going to break because of the changes to Safari View Controller. This is where we're going to come together and begin to share those. I've got a back channel to Apple, and so do several others, and we're going to try to get some sanity back into the conversation.
Different back channels?
So-
Are they correlatable back channels?
So one point on your question. So that's part of what the app attestation stuff William and I have been working on, is that for the authorization server to make good choices about what that client does, we are seeing fake clients out in the wild where they're, basically hijacking another client's redirect URI, etc. So app attestation would allow the server to actually detect clients that have hijacked redirect URIs that are pretending to be other applications. It's entirely possible to have a cute kitties app impersonate your banking app, which can have bad side effects. So we need to have a way of detecting that remotely.
All right. Thanks, everyone, for joining and the questions for the panel. Appreciate the panelists.